Hello, I'm just going to run through the assembly of one of these little preamp boards if you wish to build one into a casing in a similar style to the very expensive online ones. You can use these completely separately, just wire-ended, put it in a plastic box or metal box so long as it's insulated, with XLR connectors or between plugs and sockets, anything you like. But one of the options is to use one of these standard casings that's readily available, it seems to be, from several places, and just fit it in that so you've got a completely self-contained unit. I've found those online at different brands. Just before I forget, I mean, in the UK, you can get them for such as CPC, Farnell, or even B&Q, or obviously eBay and places like that, probably AliExpress. The brands I've seen are either Pro Signal for the CPC ones, or ones like these at B&Q, and I think these are online also on eBay as Loops brand. But as long as it looks like this with the plug and socket, the two screws and this kind of matte finish metal casing, it should be compatible. It doesn't matter which attenuation it is, it could be 10, 15, 20 dB attenuation, because that's just the resistors inside that you're going to rip out to reuse the case. Okay, so if I strip this one down, let's first get rid of the label to avoid confusion. I'll just peel off. This is coming off quite cleanly. So just put that out of the way. Then this will come apart at the ends. Just take the two screws out. Pull one end out, you can just see the connecting wires, and the simple thing to do with those is cut them. You can then poke out the plug from the other end. All the bits want removed from the sockets, or the plug and socket, just take off the bits of sleeving, which will either tear off or slide off depending how tight they're fitted. That can just be cut. There's just resistor leads. You can see the resistors and stuff in there that make up the attenuator. It's not a balanced attenuator, interestingly. It's a kind of T-network between the pins. Anyway, that's what it appears to be. So, next thing is just desolder the bits of wire that are left. These are big kind of solder bucket terminals, so they're quite easy to work with and quite easy to desolder. Bit hanging on it. That's it. Yeah, there doesn't seem to be anything through the holes in the terminals. They're just along the surface, so they're quite easy to work with. Right, now the PCB, best thing to do with that, in my mind, is mount it directly onto the pins, or very close to the pins, as we've done this one I was testing with. 3 bits of component lead, which I've got some bits of stiff wire up here somewhere. Can you find them? It's not very long. Just some saved bits of component lead. Those can be useful for things. Right. So put 2 of those on the outer 2 pins of the plug. hoping I'm still in the shot there. There we go. So it'd be easy to weight this plug down with something, but thinking it's quicker to do it without. More haste, less speed. Right, come on. Melt. There we go. And I should have done that one first because the wire's in the way now. There we go. Right. So that's the outer two pins with wires attached. They want bending down maybe 3mm behind the pins. So the shaft of a small screwdriver like that, or a 3mm drill, something like that. Ouch, that's a lot. Is a useful thing just to give it a bit of spacing. Then the output end of that, which is the end without the caps, check which way around it is. The pad that's got the white line next to it is pin 1. That's pin 1 there. So just thread two of the two wires through that. Just give it a bit of a twist and a wobble to get it seated all the way up. And I suggest soldering one first, no matter which. Solder one first and try it in the tube to ensure that it's central. You want to get it absolutely rigid with all the 3 wires soldered and find it's out of line. At the moment you can still manipulate it a bit. Now you do need to trim the wires first, of course. Cut down a bit more later, but for now that'll do. So there is a flat in line with the screw hole, so it'll only go in one way, and check it's in position. I don't know if you can actually see it, but that is nicely centered. It's got the same gap either side. It's about parallel to the base of the tube, maybe slightly lifted, but it's got plenty of space around it. So I can solder the other wire. Let's see if we can just squeeze that one in a bit more. It's a bit out. I solder the other wire. There's still a little bit of flexibility. You can bend them slightly, but better not to stress things unduly if you can get it lined up first. Right, so just go around those top as well. It is plated through, so it needs soldering top. I just like to make sure it's fully penetrated through and trim those flush. And the last one just needs bending maybe 6mm, 90 degrees. Then that'll drop through there and hook into the centre pin, pin 3. A bit of luck, like that. And use the circuit board to hold it now. Solder that middle pin. Pushed in a bit too far, there we go. That's it. That's now soldered in, and it's not quite perfectly straight, but it's not bad. It's electrically right, that's all that really matters, and it's not going to be too close to do anything else. Trim that down to the same length as the other two and solder that securely. Okay, so that's now attached. Just do a quick check with the tube positioning, and it's still, so you can't see that, and if I can get enough light on that. One of these cheap torches that loses connection every so often. Hopefully you can see something down that that the board is well centered. Now it needs 3 wires on it. Put the green at the pin 1 side, which again is the one with the white line next to it there. Brown and white. Colours aren't particularly relevant as long as you know which is ground or which is which, if you're bothered about phasing. Now if you do want to retain the phasing, because this is an inverting amplifier, the 2 signal pins won't swap in between one end and the other. So at this end, because the others are already fixed, you'd exchange these so white becomes the centre pin rather than brown on the other end. Oh, but the light is there. Okay, 3 wires soldered. Just twist the. It doesn't really matter. It's only going to be a couple of inches long at most. Doesn't hurt just to twist those up. Now it needs the transistors in. The board is marked emitter base collector. Again, if I can get it to focus on here, like it does on this time, you can just about see it's a very small print, but it is EBC. Emitters are at the same end as the input and caps and preset. Emitters on these particular transistors, which are ZTX851s, should be this left hand pin with a flat face towards me and leads down. Just double check that. Yeah, pin 1 is emitter. These should have similar gain. 291, 292, they're fine, close enough. And so it's emitter this way, collector to the plug we've just fitted, if you're building at the same time as watching. Nice. Now the transistors are a bit of a tight squeeze to get them down, because I don't like putting pads unduly close together. What I can do is just rest them on something hard, or on the edge of a desk or something, and just gradually rock the board and rock the transistors back slightly. Don't try and push them square down in one go, because it's likely to break things or damage things. But if you just keep rocking them back and forth, you can get them quite low down to the board. Then once you've done that, and you're happy with the height, which that one's got a little bit further. Oh, that reel's got recesses under the label and help them trying to get something level. Once you're happy with the height, release them, bring them back up a bit, and solder them where they're loose. That is quite important with any component when you're trying to tight form leads. See, if you leave them in the stress position, the stresses are going to be locked in when you solder the wires, and that can cause premature failure of the devices as they cycle thermally. If they're under a permanent stress with the leads being stressed and spring loaded, it can cause internal damage over time. Just solder the bases to start with. Check they're well down and symmetrical. That's just as a cross check they are. You can see the same way as those two. That's the flat side towards me with the plug to the right. Different transistors have different pinouts. You can use basically anything you prefer in this, as long as it's an NPN rated at over 60 volts and reasonably low noise. And the base is the center position. If it's not a center base layout naturally, you have to kind of rearrange the leads and put the transistors in sideways or twisted or whatever. Now this is only the second one I've assembled, and it's going to be the first one actually built into a case. So I left the other one open to play with. The other thing is, before you actually assemble it, you want to decide on the gain. With the pot dead center, the gain is reasonable. In fact, what you could do, well, in fact, probably it's a good idea really to say it. Leave the wires long, solder them straight on that, and check the gain first. Like build it like I've done that one, and then test it and set the gain up first. Once you're happy, you can desolder the socket again and build it properly into the casing. Now the gain is quite reasonable with the pot in the mid position. That brings up the SM7B, so I'm getting a good -6 level with the Focusrite interface turned full up. If you want, now also on these prototypes, the pot works backwards. Next batch I may sort of change that if I remember, but at the moment, to increase the gain, you go anti-clockwise. Now, as I mentioned in the video about the circuit in general, I'd try to avoid using the last bit of the range, because the input voltage range is going to drastically reduce, because it's effectively changing it from two symmetrical separate amplifiers to a long tail pair at that point. And the input range will drastically reduce, and you may get distortion quite easily. So keep it down to, say somewhere around 3/4 of the full range probably, or no more than like 90 degrees to the left from the center point, at a guess, to keep it reasonably linear. I mean, the thing to do is set the level on your main input that you're feeding this into to something sensible, not quite full up, but make sure you've got some spare gain, and then adjust this up so you're getting an adequate signal from the mic, rather than just winding this flat out and turning the gain down on whatever it feeds. That should give you the best quality and a reasonable noise level overall. Anyway, okay, now, so as I've not tested this one yet, and I've tested the other one, I'll actually swap to this one in case this one instead. I think it's cheating, but you've seen it working in the other video, and I know it works, so I've got no problems casing it up. I'm going to set the gain by guesswork. I mean, the other thing to do, I suppose, you could leave the leads long enough on that so you could get the gain put out. Now, those aren't quite. Oh, there might be, actually. Yeah, actually, yeah, I think if I leave them that long, I can attach it and then feed it back through the other way to get to the gain pot if I need to. So we'll try to that. To take the screw out of there so the plug will go in all the way. So I've got the maximum possible length on this end, and put that back together. Green is earth, is pin 1, which is that on that side. Now looking at the board, I've got blue centre, so I want blue on the outside of this end to maintain the phase, though it shouldn't really matter. And then red central. So that's all connected. As I say, I think now if I feed that back through. Don't forget to take that screw out, or else it's not going to fit well. Yeah, that comes out far enough to be able to get to the game pot, whilst it's wired into the casing. Could actually be half an inch shorter, almost a centimetre shorter. I'm going to turn that about 2/3 of its range. So if the neutral position is 12 o'clock, halfway, that's somewhere about 9:30 clockwise. Clock face wise, and just turn that a couple of times to get a bit of a spiral into the wire, and feed it in. So this should now work in line with the other mics. Just put the screws into these connectors so I don't lose them. Oh right, another thing I forgot to mention, I would suggest adding a little wire link bridge between the earth tag on this plug and the pin 1 ground side there, as otherwise the casing is floating, and if neither of the plugs has the casing earth, then that's a source of hum pickup. So connect it to at least one ground point, and that, the screen pin on the plug, which is not a signal pin on an XLR, it's only the power ground or screen ground. Connect that to the screen tag, and that will reduce the chance of hum pickup. I mean, depending on the XLR leads, I always link the ground pin, unless there's a very, very good reason not to the screen pin. And that's what the standards say should be done, but some places use the screen as an audio signal, which is against the specs, and that can cause weird things if you link the casings to the screen. Okay, I hope that's of interest, and thanks for watching.